Hey everybody, this is Mr. Nicholson, and in this video what we're going to be doing is we're going to be taking a look at the separation of mixtures. This is going to be the first in a series of videos on the separation of mixtures, and what we'll be doing is we'll be looking at 2 or 3 separation techniques per video. Okay, so in this video what we're going to do is we're going to look at the separation of solids from liquids. Alrighty, so our first technique is filtration. And that technique relies on the physical properties, particle size and solubility. See, when we have a finely divided material, when we actually are filtering it, we're reliant on the filter paper to actually stop it on the basis of its particle size. Okay, so in a nutshell, what actually happens when we're actually filtering a material, what we do is we take our mixture and we feed it down from a container such as a beaker into our filter funnel where we have a filter paper, alright, preferably having that fluted. Okay, now the filter paper is porous. It has a series of small holes that will allow the liquid component of the mixture, known as the filtrate, to pass through along with any dissolved solids. That's where solubility as a property comes into this. Now the filter paper, having small pores, means that it will only separate material as long as it is larger than those small holes. Now this will mean most solids will actually be stopped on the basis of particle size unless they are really, really fine. Okay, and what will happen then is once that happens, they will then pass down into the filtrate, into our collection vessel. Alright, and so just note a couple of important terms here. Alright, we have residue. That's our solid that is actually retained in your filter paper. And we also have filtrate. That is your material that is collected underneath your filter. Okay, that's your liquid that's collected. Alright, let's take a look at our next technique. Centrifugation. Now this is a technique that we use particularly when we have really fine particles that are well stabilized and that will stay suspended in a liquid. Alright, and the physical property we're using here is density, and so our particles actually have to have a different density from our liquid, otherwise we cannot actually effectively separate them. And what we do here is we actually load our particles into a centrifuge tube, which looks like this. And what actually happens when we do that, so we load our liquid mixture in, and we will then load it into a centrifuge, which is just pictured there on the right. Okay, and so when we take a look at our centrifuge, what actually happens is when we load our sample in, like so, it's actually going to be spun in a circle at about, on average, 2,000 revolutions per minute. It'll vary a little bit depending on the exact device, but that's quite a common revolutions per minute. And what will happen is the actual vial is on a hinge. So this little section here is actually on a hinge, and it will actually rotate out when it's spinning. Okay. And so what will happen is they'll actually be spinning end to end our tubes, and they will be rotating round, and that will allow them to actually undergo what's known as centrifugal force. See, when something is actually being spun around in a circle, like so, it actually, from the center of where the circle is, it actually experiences a centrifugal force pulling it to the outside. And what that means is, in terms of the particles inside these centrifuge tubes, they actually experience a net force pulling them towards the bottom of the tube, which is why the tube is actually pointed at the end. Because what that means is, at the bottom of the tube, as your particles are pulled down, they are actually collected as a pellet at the bottom just here. And that means that we can actually decant our liquid fraction of our mixture off. And that's done quite simply by pouring from the tube, and as long as we don't disturb the pellet of material, we're able to actually pour the liquid off and separate it with very little issue. Now, a couple of little things to think of just here is if you've got particles of the same density, you're going to have a really difficult time using this technique because they're not going to be separated from the liquid. The second thing is if you have really fine liquids, what they can do is they can actually hang around this air-water interface at the top of the liquid. Alright, and so sometimes you'll need to actually remove them from the top of the liquid before you actually separate the liquid from that. The liquid is also known as what's called a supernatant, and that actually and that can be removed quite easily and decanted quite easily, but again, you need to be careful not to disturb your pellet. Alright, so this is a technique that is very useful with fine particles. With coarse particles, it is still useful. It still can be done in place of filtration, but typically you will be doing this in place of filtration if you have to actually do a large number of samples. Because as you can see there, you can actually load 8 samples into the centrifuge that is pictured. And one thing that is super important is that you actually have to load samples across from each other. They have to be weighted across from each other. If you don't balance the weight, they're not going to actually evenly spin, and then they're not going to evenly move out to a horizontal position as they spin. That can either damage the machine or mean that the machine will not work as effectively. Okay, so that concludes our first video on separation. Okay, in this video we've taken a look at the separation of undissolved solids from a liquid. In our next video what we're going to do is we're going to take a look at the separation of dissolved solids from liquids. Thank you. See you.